Today's video is on moment generating function, and the problem here today is obtained the moment generating function of a random variable x having the probability density function f of x is equal to x when x lies between 0 and 1, 2 minus x when x lies between 1 and 2, and 0 elsewhere. See here, coming to the moment generating function, the moment generating function of a continuous random variable x is given by mx of t is equal to integral minus infinity to plus infinity e power tx f of x dx. So in between minus infinity to plus infinity, I have to introduce these limits 0 to 1 and 1 to 2. See here. So integral 0 to 1, this is e power tx f of x dx, and the next one here is 1 to 2 e power tx f of x dx. Elsewhere the function value is 0. And now see here, integral 0 to 1, this is e power tx. So in between 0 to 1, what is our f of x value? So in between 0 and 1, f of x value here is x. So here the value here is x into dx, and in between 1 to 2, the function value here is, in between 1 to 2, the function value here is 2 minus x. So this is 2 minus x into dx. And now we have to do integration by paths. So this is u and this is v, and here this is u and this is v. So I'll tell you that is integral uv dx is nothing but u we have to leave for one time, v we have to integrate, minus integral d by dx of u integral v dx whole dx. So this is the formula. So in this formula, if we keep this one, see what happens. So u we have to leave as it is. So if I leave u, that is x, and v we have to integrate, that is e power tx. So with respect to x, x is 1. So what remains here? T remains. Minus integral derivative of u is 1, and the integration of e power tx is again e power tx, and for x it is 1, t remains. So this is dx between the limits. See here, the limits are from 0 to 1. And see here, this is also uv. So u I am going to leave, that is 2 minus x I am leaving. Again I have to integrate this one. So again I have to integrate v, that is e power tx. For x it is 1, t remains, minus. So 2 constant, so this is minus 1 e power tx by t into this is dx. This is tx. So this is equal to, this is x e power tx by t minus, so this is e power tx by, for x1, so this is t square between the limits of 0 and 1. And here if you observe, this is 2 minus x e power tx by t minus, minus of minus, this is plus, this is e power dx by, for x it is 1. So what remains here? T square between the limits 1 to 2. So these are the limits from 1 to 2. Now we have to substitute upper limit minus lower limit. So if I keep 1 as upper limit here, so this will be e power t by t minus, if I keep 1 in place of x, that is e power t by t square minus, if I keep the lower limit 0, this is 0, and if I keep the lower limit, that is minus of minus plus 1, anything to the power of 0 is 1, so this is 1 by t square. And now coming to this one, if I keep 2 as an upper limit, this is 2 minus 2, 0. The first thing is 0, and next if I keep 2 here, this is e power 2t by t square minus, so if I keep 1 here, 2 minus 1 is 1, that is e power t by t minus, so if I keep in place of x as 1, this is e power t by, this is t square. This is t square. Now, if I multiply this one, that is e power t by t minus, this is e power t by t square plus this is 1 by t square plus this is e power 2t by t square minus e power t by t minus e power t by, this is t square. So here we can easily cancel this one, e power t by t plus, and this is minus, and what remains here? So this is e power 2t by t square, and this is minus and this is minus. This will be 2 times of e power t by t square, and here this is 1 by t square. So if I take t square as LCM, this will be e power 2t minus 2 into e power t plus 1. So this can be written as e power t whole square, a square minus 2a into b plus this is b square by this is t square. So this is a square minus 2ab plus b square. So this is nothing but a minus b whole square by this value is t square. So here the whole value here is the function value is e power t minus 1 by t whole square. So this is e power t minus 1 whole square. This is the moment generating function for the given function. See, so let me explain you once again. See, this is the question. So we have to obtain the moment generating function of the random variable x having the probability density function. So here we know that the moment, according to the moment generating function, mx of t is equal to integral minus infinity to plus infinity e power tx f of x dx. So I have to introduce the limits 0 to 1 and 1 to 2. So after introducing 0 to 1 and 1 to 2 and substituting the function value here as x and here as 2 minus x. So I have to apply integration by parts. After applying integration by parts here and substituting the limits here, and here is the answer. The final answer is e power t minus 1 by t whole square is the answer. And thank you so much for watching, and I'll be uploading 2 more questions related to these series. Have a look at those and please practice definitely. Those are very, very important. And if you really like this channel, please subscribe to this channel, pass it on to your friends and raise your thumb. Thank you.